Back to number 5. Just like all the rest, we're going to start by factoring. So in the numerator, I will have x squared times x plus 2 over, and then I will have x minus 3, and then this will be x plus 6, x minus 3. Okay. Do I have any point discontinuity? No. I have 2 roots, right? I've got -2 and 0. How many vertical asymptotes do I have? 2, because I really need to rewrite this again, right? I've got x squared times x plus 2. So if you didn't already notice it, which some of you may have, when you go to look at your vertical asymptotes, you should be like, hey, those are the same. So that should be x minus 3 squared times x plus 6. All right, so vertical asymptotes, I have 2. X equals -6, x equals 3. Do I have any tangency or togetherness? I have both, right? I have tangency where? It's on the numerator, so it's this 0, which happens to be 0. So I have tangency, that's at a point, and it's at the root that is 0. I have togetherness. The togetherness goes with an asymptote, and that's going to be at x equals 3. Do I have a horizontal asymptote? Yes, y equals 1, good. Which means no slant asymptotes. And my y-intercept, since one of my roots is 0, my y-intercept is 0, 0. Okay, so I'm going to rewrite f of x equals x squared times x plus 2 over x minus 3 squared times x plus 6. Okay. So on my number line goes the -6. Oh, that's not a 6. -6, the -2, 0, and 3. So the 3 and the 6, or the -6, are my asymptotes. These are zeros. So I've got, for my number line, I have tangency and togetherness, and that's going to help me not have to pick signs for each one of these. My tangency is here at 0, and my togetherness is here at 3. So I really only have to do my first set of signs. If I choose a -7, that'll give me positive, negative, positive, negative. That's positive overall. So then the signs alternate unless I have tangency or togetherness. So if this is positive, this is negative, this is positive, but then I have tangency, so it stays positive. I have togetherness, so it stays positive again. So my graph is positive, negative, positive, positive, positive. Because here is my tangency, so it's going to bounce and come up like this, and then my togetherness means it's going to look something like that. Okay? That'll help me figure things out when I get over there. So let's get our asymptotes on here. I've got one at -6. One at 3. And one at y equals 1. Then the points I can plot, I have -2 and 0, and that's pretty much it. So from -infinity to -6, my graph is positive the whole time. So it should look something like this, but I got to get at least 1 point in there. So I'm going to have to choose them in this case. This is -6, so I'll choose -7. We find f of -7. That'll give me 49 times -5 over 100 times -1. So if I reduce this before I multiply, that makes that 1, that makes that 20. Everything's positive, so I get 49 over 20. Which is about 2.5, right? Oh, but this was negative and negative. So, but yeah. So it's about 2.5. So I'm going to -7, 1, 2.5. I feel like that's enough. But I can't graph it in yet because I haven't figured out whether or not across the asymptote. But that's going to be enough for that section. between -6 and -2, it's negative, so that makes sense like this. And then -2 to 0, it's positive, and then it's going to bounce, and then it's going to be positive again. So I know for sure I'm going to cross it at least once right here, but that's probably going to be enough points for me to figure things out. But I'm going to need a point, at least 1 point over here, so I'm going to do f of 4. That'll give me 16 times 6 over 1 times 10. So I can make this 5 and make this 8. So I get 48 over 5. So that's like 9 3/5 over here, and then 9 3/5 is about right there. That definitely doesn't really help me. So I'm going to also do f of 5, which will give me 25 times 7 over 4 times 11. Okay, so nothing can reduce first. If you have 7/4, how much money you got? This is not a hard question. I give you 7/4. How much money? 175. There you go. 175 over 44. So that's a yucky one to try and figure out. But guess what? This is what we're estimating anyway. We can't get super accurate, right? Nobody's asking me for the actual number. I just got to get it in the ballpark. So what if I said, all right, this is almost 44. Let's make this 45. Then I can reduce that a little better, right? I know that I can reduce them both by 5. So this will give me 9. And then 5 would go into 17 3 times. So it'd be 9 over 35. Or I'm sorry, 35 over 9. Ugh. And then that's almost 36 over 9, which is what? 4. So we're in the ballpark of 4. Good enough for my graph, right? So I can go to 5 and then go up to 1, 2, 3, 4. That's how you can kind of finagle things when you're estimating to get the ballpark of it's about 4. So that's probably enough. But again, I'm going to have to check to see if I cross the asymptote. So I don't want to do any. I don't want to actually draw anything in just yet. So in order for me to check to see if it crosses the asymptote, I need the unfactored version of, so I didn't reduce. So basically I just need the unfactored version of the original. And so my numerator can stay x cubed plus 2x squared. And then I'm going to have to distribute both of these things. So I distribute the x and I get x cubed plus 3x squared minus 18x. I distribute the -3. -3x squared minus 9x plus 54. Clean it all up and get x cubed plus 2x squared over x cubed. These zero out, and I get -27x plus 54. Okay, so sometimes we got to multiply things back together to be able to use them. Everybody with me on where everything came from and why I'm doing it? Awesome. So I'm going to move down here where I have room to work. I'm going to rewrite it though. So I've got x cubed plus 2x squared over x cubed minus 27x plus 54. What do, excuse me. What do I set that equal to? 1, because my asymptote is y equals 1. All right, 1 is great. So then I just multiply both sides by the denominator. We get x cubed plus 2x squared equals x cubed minus 27x plus 54. So now I just start to solve. Subtract x cubed from both sides, those zero out. I don't have an x squared to cancel that out, which means I'm going to have a quadratic. So I need to set it equal to 0. So I'm going to move everything over to the left. So that gives me 2x squared plus 27x minus 54 equals 0. So at this point, I would factor, but I'm going to tell you this one doesn't factor. That's why this one is an example one and not in an assignment one. If I can't factor, my other option to actually get zeros would be to use the quadratic formula. So that's what we would need to do here. We're not going to take the time to do it because it takes time. I'm just going to tell you what you would get because that's what matters here more. So your x's end up being estimated at -15 and 1.8. So that means that the function crosses the asymptote twice at those two x values. So the first one is out here at negative 15, which is way off my graph, but this would come down, it would cross down here wherever negative 15 is and then come back up. Then the other one's at about 1.8, which is about right there, which we knew it was going to cross somewhere right there because it's got to stay positive, okay? So got to check for them, plot them if we can. So now I can go back and draw this in. This part looks like this, crosses somewhere over there, but I can't do anything about it. From negative 6 to negative 2, it stays negative, so it looks like this. From negative 2 to 0, it's positive, and then it bounces, and then it's positive again, like so. Excuse me. I have togetherness, which I can tell from my points anyway, and I know I don't cross the asymptote over here because I've already checked for that, so it should look something like that. What questions do you have? Anything? Is this getting easier and easier, making more sense? Hopefully. All right, let's look at number 6, because something's even very different about this one. So we're going to start by factoring, and this would give me 2x minus 3 times x plus 3. And then can I factor the denominator? No, I can't. So it just stays x squared plus 3. All right. No point discontinuity. I have 2 roots. I have one at negative 3 and one at 3/2. Do I have any vertical asymptotes? No. And if you're unsure about that, remind yourself that those are the zeros of the denominator. And if you try and find the zeros of the denominator,
that we need to submit our 3rd period attendance, but it's also a reminder that we need to be signed up for math time, so let's make sure that everyone is signed up.
And I would get imaginary numbers, so I have none here. So this is the first one we've had where we don't have any of those. I also do not have any tangents here at togetherness. I know I have an even exponent, but that's not an even exponent on a factor, so this is none right here. Do I have a horizontal asymptote? Yes. Y equals what? 2. Very good. Then no slant asymptotes. My y-intercept is going to be 0, negative 3. All right, so let me rewrite this and get our number line going. F of x equals 2x minus 3 times x plus 3 over x squared plus 3. All right, so I've got my negative 3 on here and my positive 3/2. I don't have any vertical asymptotes to put on there. I also don't have any tangents here togetherness. So if I find this first one, then I know it's just going to alternate. So if I choose a negative 4, that's going to give me negative, negative, positive. So that's positive overall. Then this is negative. That would have to be positive. So my graph looks like this. So let's get our asymptotes on here. Oh, just asymptote. All I have is this y equals 2. Then I need to plot my points. We've got a root at negative 3, one at 3/2, and then a y-intercept at 0, negative 3. All right, so I know from negative infinity to negative 3, my graph is positive. Then it's negative from negative 3 to 3/2. That makes sense that it's positive. So I know the shape of what it's going to look like, but I need to figure out whether or not it crosses my asymptote. So I take my unfactored version, which is 2x squared plus 3x minus 9 over x squared plus 3. Set that equal to what? 2. Very good. Multiply both sides by the denominator. So I still have 2x squared plus 3x minus 9. Then when I multiply, I'm going to distribute at the same time. So I get 2x squared plus 6. Then I solve. So subtract 2x squared from both sides. Those zero out. Then I can add 9 to both sides. So I get 3x equals 15. X equals 5. So when x equals 5, That's when I cross my asymptote right there. Now I have everything I need to do to draw this in. I know this has to stay underneath the asymptote to stay positive to get there. Then it's negative, got to hit my y-intercept and come back here. Then it's going to be positive, I cross the asymptote. But we don't know how far we go up, but we do know that we have to follow the asymptote back down, okay? Because that's your end behavior. And that is what it looks like. What questions do you have? We good? Awesome.